Jump right in. Okay, so just like number one, two numbers that multiply to 14, but add up to 15. What would those be? If you need to, you come off to the side and you write all the factors of 14.
It'd be 1 and 14.
Yeah, so x plus 1, x plus 14. Now, did you get any indication, like, are you going to get one of each type of problem, or could be many of each type? Anything like that?
It'd be many of each type.
Okay. Well, maybe it'll be sort of in this order where you know what to look for. Okay, so number 3 here, a little bit more difficult question. I'm gonna just reframe the problem here. You should always start with GCF. GCF here. Is that okay?
Yeah.
So look at the number here, 8, 32, and 96. Is there a number that goes into all three of those?
Okay, let me think.
And you're allowed to use a calculator?
Yeah.
So I would grab a calculator and just try the smallest number. Does 8 go into 32? And does it go into 96? Just divide them. And then you know right away. You're like, all right.
Yeah, it does.
Right. That's good. Now the next thing is what's the smallest x power? We got x cubed, x squared, x to the 1. What's the smallest one?
X to the 1.
All right. So now that's what you're going to factor out of all three of them. So you're going to divide each of them by 8x. Let me know what you get in parentheses, please.
4x minus 12.
So we get x squared plus 4x.
Oh yeah, x squared.
Yeah. Right. Now you might think okay, I'm done. It's a GCF, but you actually can factor the inside, and that's where you've got to know to keep going, and you keep going until you can't factor it anymore. Unfortunately, there's no good way to know. You just have to keep going. So if you see 3 terms, you're going to keep going. 2 numbers that multiply to minus 12 but add to positive 4. Okay, so that's like minus 1 and 12, 1 and minus 12, minus 2 and 6, 2 and negative 6, negative 3 and 4, 3 and negative.
Minus 2 and 6.
Yes. And coming up with this list is really, really important here. So x minus 2, x plus 6. Bring that 8x down. Don't forget to do that one. Any questions on that before we move to another one?
No.
Okay. Are you comfortable making this list on the right?
Yeah.
Okay. All right, so here we go. Number 4, you always start with GCF factoring. Always, always, always. So what is the GCF between 5 and 45? And I'd always just recommend trying that smaller number. Hopefully it
5.
works. Yeah. And then between the two x's, x cubed and x, the smaller one is x. You're going to divide each of these by 5x. So let me know what is inside parentheses.
Five x cubed minus 8.
The fives cancel when you divide.
Okay.
So that's x
That'd
squared.
be just x squared matter.
And then what is 45 divided by 5?
Oh, it's 9.
9 minus 9. So the second type of factoring you're always looking for is difference of squares. Is this difference of squares inside here?
No.
So it is, but you have to get it in this form, a squared minus b squared, meaning you have to know what squared gets you back to 9 and what squared gets you back to x. So this is x and 3. And that's your a and your b. So your a is x and your b is 3, and it becomes a minus b, a plus b.
Oh,
Is that okay?
yeah.
So what does this factor into? What does x squared minus 9 become? And you've got to use this difference of squares on the right. What does it become?
Becomes x. X. X.
Got
Yeah, x minus 3, x plus 3.
very good. And then just bring down that GCF as well. That's the final little piece to that. Any questions on that before we move on?
No.
All right, so number 8 is the next one we're going to go to. We're going to come back to 5 and 6 and 7, but 8's more like number 4. So we're going to look at that next. All right, so is there a GCF here? And if so, tell me what that GCF is.
10.
Okay, how about and a letter? Is there any letters that go into both?
10x.
Good. So you divide each of these by 10x. Tell me what goes in parentheses, please.
Three x plus 1.
You got it. Now, is this difference of squares inside here?
No.
It is not. So you are done right here. All right, so we're going to go back to 5 now, and I really like what you have done here. It's great to see this because it makes me think that you really got this stuff down. You're going to take 3 and multiply by minus 6. So make sure you apply that sign to it. Minus 18. Two numbers that multiply to minus 18, but add to minus 7. Could you tell me those two numbers?
Sure. Uh, 2 and minus 9.
Yes. So you got a choice here, and I'm going to suggest we go minus 9x plus 2x minus 6. So the whole point is to split that apart, there. Now, do you remember what to do from here with the factor by grouping?
Yes, I think it was
So you look at those two and find the
the
GCF again. And that is 3x. 3x. So you're dividing each of those by 3x. Tell me what goes in parentheses, please.
x minus 3.
Okay. And that's what you immediately write off to the side here.
And the part in the middle is plus 2.
Plus 2, good. Okay, and then you pair you're essentially factoring out the x minus 3. So it becomes 3x plus 2.
Okay.
So I'd like you to try 6 on your own. You're really close. I mean, what you tried to do, you do not need to multiply the 3 and the 12. But go ahead and try that one on your own, please. And let me know what you come up with.
All right. A 4 and 9.
Okay, yeah, keep going. That is correct. And that's probably why you had them in the what looks to be like an erased part there. But yeah, you're going to use that as well. I would probably go 9x plus 4x because the 9 pairs better with the 3.
Yeah, 3x plus 4 and x minus 3.
It's going to, they have to both be positive.
Oh. Where's my error?
I heard all the right stuff up until then because it's 3x squared plus 9x plus 4x plus 12. And then you factor out a 3x plus 3. Ooh, that's an issue. Should be 3x plus 3. And then you write, I'm sorry, x plus 3. I'm making bad mistakes here. Okay, x plus 3, and then plus 4. So 3x plus 4, x plus 3. Maybe just a stray minus sign.
Yeah.
All right, let's look at the next one here, number 7. This is number 7 here. This one's kind of already in that grouping form. So you just find the GCF between the first two. Can you tell me what that is?
5x squared.
5x squared, perfect. And then inside parentheses is 3x plus 2. So you'll write 3x plus 2 over here, and in that space in the middle, tell me what goes there.
-3.
-3, perfect. So it becomes 3x plus 2 times 5x squared minus 3. Any questions on that before we move to the next type of problems, the solving?
No, all good.
All right. Number 9 here. So we talked about this, I think, the other day. How many solutions do quadratics have?
1 or
So here's a quadratic. Here's the line. Where how many times the line intersect the
Yeah.
u? 2 times.
it'd be 2.
The reason I say that is you want to think that going into this section, because you could very easily not get one of the answers and then get half credit on everything. So if you remember, it's plus or minus when you take a square root.
Yeah.
Okay, so x equals plus or minus, what is the square root of 64? If you have a calculator, you're welcome to use that.
8.
Yes, so those are your 2 answers for that one. Now 10 is very similar, but it's not exactly the same. So you have to isolate. You have to isolate the x squared. So you're going to divide by 5 on both sides here. And you might say, well, I'll just take a square root, just like we've been doing. And that's fine. You can do that. But this is not a perfect square root. And that's where it says to simplify all radicals. Okay, so if you recall, we have to build a little tree here. Start with 2. 20 divided by 2 is 10. Try it again. 10 divided by 2 is 5. If there's a pair, you bring the pair out. So this becomes plus or minus 2 square root of what's left over. The 5 is what's left over.
Okay.
11, you've done really well on. My question to you, or I guess want to know, is did you just pause because you ran out of time, or you didn't know what to do from here?
I ran out of time.
Okay. All right. So if you keep going here, it's actually very similar to the last one. You're going to divide both sides by 4. Which gets you down to x squared equals 11. This is where you have to take a square root of both sides.
Yeah.
All right, so unfortunately, this one doesn't have a perfect square root again. So it's plus or minus the square root of 11. X equals plus or minus the square root of 11.
Okay.
Any questions on that?
No.
All right. All right, so new problem here, number 12. It's kind of the same, but not completely the same as the previous ones. Your goal is to undo the square. Okay. Like you really want to look at this as u squared equals 16, meaning u is your variable, because you know what to do. You take a square root of both sides.
Yeah.
So you should do the same thing here on the left. You should take the square root of both sides. The square root undoes the square. What is the square root of 16?
4.
Good. So this is where you might have seen like a case 1, case 2 scenario. You set x minus 3 equal to 4 and x minus 3 equal to negative 4, and you solve each of them separately.
It'd be 7 minus 1, or 7
Yes.
comma minus 1.
Yes. Sounds right. X equals 7, x equals negative 1. Perfect. Okay, back to, we're going to the other side of the paper now. Okay, so we're kind of transitioning, kind of like what we were doing actually in number 10 is 13, 14, 15, 13 and 14. So we'll look at those together. All right, so you start by building that factor tree. Start with 2. Okay, you got a calculator, 150 divided by 2. You can do that. That's 75. Then you say, okay, well, 2 doesn't work. So you try 3. 3 is the next number to try. Does 3 go into 75?
Yeah, 25.
25. You try 3 again. 3 does not work. You're like, man, that's pretty frustrating. 5 is your next prime number. 5 works twice. So it doesn't matter where the pairs appear. Like they could be down here, but you bring one out. So you bring a 5 out. What's left over has to stay inside 2 times 3. So this becomes 5 square root 6.
Makes sense.
All right, I'd like you to try 14 on your own. And if you have questions, please ask. It's kind of the same. I mean, it's a different number, but not exactly, but just see where you're at on that.
All right. I forget if it's 2 pairs of 2 in the factor tree. Are they?
They both come out.
Okay.
So it'd be 2 times 2 times 2. That's a good thing to remind yourself of.
I don't think this is right, but 4 times the square root of 3.
It is correct.
Oh.
Got to get you to have more confidence. All right, so the next ones are newish, I guess, different-ish. Maybe we did some on the other day. I don't recall, but we're going to break these down into things that you already know how to do. All right, so 15 is the square root of 12x to the 6th. It's really, though, the square root of 12 times x to the 6th. And then you can break each of those apart into a separate problem. So there's this property that allows this to happen. Okay, so the one on the left, that's like what we've been doing in 13 and 14. So will you try that and let me know what you come up with?
Two times the square root of 3.
Good. All right, now for the x to the 6th, there's a couple ways you can do it. I don't remember what we did last time. Do you remember, did we break it up into like x cubed and x cubed, or did we use the exponent rule? Any idea?
I think it was like kind of the same as like with normal number, like
So we probably did
Yeah.
like x cubed like that.
yeah.
And since they're the same, you can bring it out.
Yeah.
All right, so that becomes 2x cubed square root 3. And that is it. We're probably gonna do one more like this. We got plenty of time here just to, or I guess maybe I should just ask some separate questions here. How about, like, what is the square root of x to the 8th? What does that become?
Um, x to the 4th times x to the 4th.
Yes, it just becomes x to the 4th.
Oh yeah, because it's I forgot about the square root. It's kind of just cut it in half with the exponents.
Yes, exactly. That's all it is. Okay. You just cut it in half.
Yeah.
All right, so now let's look at number 16. So just like the previous problem, you're going to break this part into square root of 16 times the square root of x to the 11. The square root of 16 is a known value. That's 4. That's nice.
Yeah.
Okay.
And
then for the one on the right, this is where it's a little bit more difficult. You have to change this to x to the 10th times x to the 1, because 10 plus 1 adds up to 11. So you break it down, though, into the even one, because that's what you're going to do. You're going to cut it in half, just like you mentioned for the previous one.
So x to the fifth.
Yes, and so that comes out 4x to the fifth square root of x. So why don't you try the square root of 40x to the seventh, which is kind of a mixture of 15 and 16.
All right.
How are you doing on this one?
Pretty good.
Okay, just keep going.
I got x to the third times the square root of 10.
Anything else? There's some things missing.
10x. 10x.
10x. Okay, anything on the outside? Any numbers?
2.
Yes. There it is. Good. All right, let's do 17 and then we'll see what we got time left for to review other stuff. All right, we want to find the shaded region. So that like when I look at this, I think of it as the larger one minus the smaller one. Sometimes it's good to even separate them like that. Right, so we have to find the area of the larger one, which is base times height. That's what I think you were, looks like you might have been about to write 2y plus 7 times 3y minus 2.
Yeah.
All right, so you have to FOIL that. You can do that now or later. On the one on the right, you're going to multiply base times height, y times 2y minus 1. So why don't you FOIL the one on the left, please, and just tell me what you come up with.
All right.
How are you doing on this one?
I made a little mistake and I'm kind of backtracking and trying to find where
Okay,
where
so
that happened.
2y times 3y, 6y squared. 2y minus 2 is minus 4y. 7y plus times 3y is plus 21y. 7 times minus 2 is minus 14. Does that look?
Okay, I see now.
So we got 6y squared plus 17y minus 14.
Yeah. All right. Yeah, I got it now.
Now on the right, you're gonna distribute in first, but then you have to negate everything. So it's 2y squared minus y, and you've got to negate everything. So you distribute the negative 6y squared plus 17y minus 14 minus 2y squared plus y. And then you combine like terms. So the y squared you'll combine, the y's you'll combine.
Okay, so it would become
It's not right.
6y squared plus.
So the 6y squared goes with the minus 2y squared.
Oh yeah, I see now.
Yeah.
The 4y squared plus 18y minus 14.
Good. All right, let me know when you get all that down.
I got it.
All right, so we have the time we have left. I can sort of pick some problems like the ones that we've been doing, or if you have a specific section you want us to go back to and do more of one or the other. What would be best? Actually, let me
want to
go ahead.
I kind of want to do some of the radical stuff.
Yeah.
'cause-
So let's say it's 2x plus 1 squared equals 98. This is a new problem. It's kind of like the 12. It's notice kind of maybe there might be some certainty here. So first thing you do is you actually divide by 2, because you really want to isolate that squared.
Okay.
All right, now you're going to take a square root of both sides. Okay, so you're going to take a square root of x plus 1 squared equals plus or minus the square root of 49. Can you tell me what the square root of 49 is?
7.
So plus or minus 7. So this is where you go like type 1 or case 1, case 2. There's 2 equations here. X plus 1 equals 7. X plus 1 equals minus 7, like that.
Okay, so it'd be x equals 6 and x equals -8.
Good. Let's see if we can get one more in here. Minus 5x² plus 3 equals minus 77.
All right.
You gotta isolate the x², first subtract 3 from both sides.
And then it's find the GCF from there, right?
Well, you divide by
Oh,
the
yeah.
minus 5, yeah.
Okay.
What are the two answers to this one?
Um, 4 and -4.
Yes. Very good. All right, we're going to